Hello again, it's Parametric Design course at the University of Queensland. Christina here, and now we're going to move on with a parametric object. Let's start with the point, as usual. Point in rhinoceros and point here in grasshopper. Point assigned. Now let's create a polygon. We know already it's located in curve, primitive, polygon. Here we go, and here is the plane, which is our point, which can be moved wherever we want, I remind you. Now we have radius, number of segments, corner fillet radius, and let's probably have a slider, and maybe it's 36 for the radius, and we'll have 5 segments. I don't really feel like making rounded corners, but we can do it later. Then let's see what can we do with this polygon to make a shape, a 3D shape out of it. We will need to transform it. First of all, we will need to create multiple copies that we will manipulate later. How do we do that? We are going to move it. So we're going to transformation. Here we go. And here we go to Euclidean move. That's what we're going to use. This one requires input geometry, which is our polygon. That's easy. It's moved on some distance. And this is our curve, which is moved somewhere. But that's not the point. What we want to do is translation. As in Rhino or any other design software, it asks where to move actually, with translation. Here it is, translation vector. Vector will specify a direction. So we would like it to be moved vertically. We go to vector, vector, and unit Z means it's going to be moved vertically up. But so far it will just move it on, let's say, 7 up. And it's just one copy, but we would like to have multiple copies of it. How could we have it? Multiple copies as multiple floors of the building. We need a tool called Sirius, and it's located at Sets, Sequence, Sirius, and it will create a series of numbers. See what changed after we introduced Sirius? There are many copies of it. Just one copy as we just created by moving it, or multiple. Then we can specify start, first number in the series, step size, and number of values. Well, this one can be specified if you wanted it to be kind of offset, but we're going to do something like that. Number, no, I want this one. Step size will be maybe 5 actually. And then number count will be 40. No, I don't like it. I want it the other way around actually. Let's make it like that. Yeah, makes more sense to me. So the step is 5. It's the distance between the copies. See? Let's keep it 5. And the count is the number of repetitions, which can be basically anything. Let's move on, and so far we'll leave it empty because we don't want that. Now we got a straight tower of polygons, and what would we like to do with that? Let's rotate it using rotate 2, which is located at the same place. Transform, Euclidean, rotate. The same as move. That's easy. So what about the geometry? Since we want all the polygons to turn around, well, geometry is basically here, which is easy. And you see it's all kind of turned, but it's turned around central point here. And what we would like to do is make it turn around the plane. It will specify, and it's going to be the center of our polygon. So how do we specify the plane and the center of each polygon to be used as the center of rotation? We need to go to surface, analysis, and pick this one. It's the area. It will pick the center of our polygons. So it's going to be centroid. Angle. Now that we have our rotation center, which are these points here, we want each of the polygons to rotate around this point. And that's when we'll need to have sequence again, to make them all rotate kind of independently. So sets, sequence, Sirius. Here we go. And we'll connect it to here. The count will be the same as the number of floors of our polygons. So it's going to be 40, like here, and we can just connect it to here. Then port N, this port, it defines the step size for each number. It's written here. We'll keep it very low. Let's say something really below 0 this time, and I will explain you why. So let's go to here. To avoid manipulations with the angle, because just so you keep it in mind, in this version of Grasshopper we have our angle in radians, and be careful with that, because our rotate component is using radians and it's not degrees. Radians measure angles by distance traveled, or angle in radians is arc length divided by the radius. A circle has 360 degrees or 2p radians. Going all the way around is 2 multiplied by p multiplied by radius. So a radian is about 360 divided on double p, or 57.3 degrees. We can change it to degrees if needed, or set an expression for it, so it's like degrees, and set an expression is here. But let's leave it this way now for this exercise, and we'll come to this later. So to see what numbers we've got, we can use the panel Here we go. That's the numbers in Sirius that we got from this operation. Now, do we need that? No, not really. So now we have each of our polygons turning around central point that we have specified using this area tool. It found the center of each one of them and made it, you see, centroid here, and used it as the plane to rotate our tower. So now we have in this rhinoceros window an overlap which stops us from seeing stuff. So let's hide everything we saw before that. Here we go. By dragging the slider, we can change the rotation. Nice and easy. But let's continue. It's not the end, and now I'm going to scale our tower using the same set of techniques we applied to transform our object before, Sirius. First of all, scale taking geometry from rotate. Let's first take scale. Here it is, it's scale. Here is our rotate. Well, I don't want to see this point. Geometry, and connected to geometry here, so it will use the same geometry. See, it's kind of started to act, but that's not what we want to do with that. We want to do something fancy. Then center will be center of our scaling will be these points here, so we'll have to connect it here. You see it's changing now, and then we have factor of our scale, and here is when we need Sirius again. So let's go to sets, sequence, Sirius, and put it here. So far it's, you see it turned red because something is wrong, because Sirius is not specified and it kind of does weird stuff now. So for the Sirius, the count is the same as it was for this set of Sirius, and for this set of Sirius it's 40, it's the number of our floors. So we have to connect this slider to here, and then we will specify step size, I mean, and we could use actually this one, but let's make it something else. Let's call slider and make it probably 0.045 at this point. Yeah. The start, you see it kind of goes to 1 point, so let's specify start and make it 1, so it starts with 1. Yeah, that's way more. So what's the difference? Here our scaling is kind of tied to the base point. Now it's 0 and it's 0 here, so it goes down to 0 factor. But if we introduce number here, it will start with number with the 1 value and give us more interesting outcome. And again, I don't want to see that. Let's get rid of this. Here we go. And the last thing I want to show you is loft. So we'll make a shape out of that. Geometry loft. And that's how we have a nice, beautiful vase that can be manipulated the way you want.